Hello everyone. In this video, we will learn how to implement XOR gate and XNOR gate using minimum number of NOR gates. So this is the favorite topic from interview point of view. So we will see one by one. Let's start with implementation of XNOR gate using minimum number of NOR gate. So as you all know, what is the expression of the XNOR gate and NOR gate. So first we will write that and understand how we will implement. So as you all know, this is the symbolic representation of XNOR gate. So if the input of XNOR gate is A and V, then we will get the output expression as A into B plus A complement into B complement. Okay. Now let's write the NOR gate expression as well. So as you all know, if there is two input in NOR gate, then we will get the output expression as y is equal to A plus B whole complement. Okay. So now our task is to implement this expression using this expression. Okay. Now before starting the implementation, let's observe the output expression of these both gate, XNOR gate and NOR gate. So we can rewrite the XNOR gate expression in XOR gate format as well. Means what I mean to say here, we can write this expression in XOR gate expression as well, because XNOR gate is nothing but it is a complement of XOR gate. So if we will write the expression of XOR gate and we will complement that expression, then we will get the same XNOR gate expression. Okay. So why I am rewriting this XNOR gate expression here? So try to connect from the NOR gate expression, this expression. Okay. So we have the NOR gate expression in this format. So I have converted this expression in NOR gate format so that we can connect these both implementation. Okay. So see here, we have one term here in NOR gate A and the second term is SV, and there two terms are OR and the whole complement present in this expression. Similar format in this also, we have one term here, second term is there, and no OR, and then whole complement is present here. So now what we will do, if we will implement this term individually and this term individually, then these both term we will pass through the NOR gate like that. Let's suppose this is the X and this is the Y. Okay. Then if we will pass these both term to the NOR gate, then we will get X plus Y complement, and that is nothing but this is a XNOR gate expression. So that is all we are looking to implement here. Okay. So now our task is to implement this term, means X term. What we are calling X term is A complement into B, and Y term. What is the Y term here? A into V complement. Okay. Now let's implement the X and Y term individually using the NOR gate, so that we will connect these two terms to get the final XNOR gate output. Okay. So as you all know, we have the NOR gate output expression as, if there is two input A and V, then we will get the output expression as A plus B whole complement. That expression we can rewrite in this format as well, A complement into B complement. Now tell me one thing, we need X means A complement into B, this expression from this expression. So what we can change in this expression so that we will get this, but we need to use NOR gate. Okay. So if I will say, if I will add A into B, means in this expression, if I will add A, then can I say I will get this expression? How? That we can expand in this format as well. That will expand in this A complement into A plus A, B complement plus A, and this A complement plus A will be 1, and the remaining coefficient, what the coefficient will remain B complement plus A. And we know if we will complement this, then we will get A complement into B. So this is nothing but this is the X. So from this we will implement X term if we will add in this expression A. So let's implement X from this concept. So we know this is the NOR gate that we have seen just now. If we will add A here in this output, means this is the output. If we will add A in this output, then we will get, means here if we will add A, then we will get here as output as A complement into B. This we have seen from this concept. So from this we have implemented the our X term. Now similar format we will implement the Y. So what is the Y? Y is A into B complement. So similar to the X, what we can change in this expression, NOR gate expression, so that we will get this expression. Okay. So if I will say, if I will add A complement into B complement in this output expression of NOR gate B, then I will get this expression. So similar to the X, if we will simplify this, then we can say we will get A plus A complement plus B into B complement plus B. And this B complement plus B will be 1. Then we will get the A plus A complement plus B. And the complement part is there because of the NOR gate that we have seen here as well. So this will be become A into B complement, and that is nothing but this is the Y complement, Y term. So from this we have seen we have implemented X and Y individually. So how the Y is coming? So Y is coming from this concept. If we will connect this output to the another NOR gate, and the second input we will provide as V, then we will get Y as A into B complement. Now if we will connect these both output that we have seen in starting as well, here as well, if we will connect these both term to the NOR gate, then we will get the final XNOR gate output. So if I will connect these both gate output, means this X term and this Y term into again a NOR gate, then here I will get the output expression of XNOR gate. Okay. So I think you have understood this from the implementation part. Now observe one thing. We will simplify this expression as well, because here if you will observe, then we have used these two NOR gate in same format. So in question it is mentioned using minimum number of NOR gate. So we can use one NOR gate instead of two NOR gate to minimize the number of gates. Okay. So if I will rewrite this circuit again, then I will take the common output of this NOR gate. Here A and V is connected, and this common output going to the first NOR gate, and that NOR gate is connected to the A input, and similar to the this side as well, we have connected this output to this NOR gate, and here the B input connected as we have seen here. So this is the X term and this is the Y term, and that output of these two terms are going to connect in again a NOR gate. Here we will get the final, means let's suppose this is the final output as Z. So this we will get here as XNOR gate. So that is all we are implementing from this question, and this input we can take from the common point. So this this is the final implementation of XNOR gate using NOR gate. Okay. Now let's move towards our second question, that is implement the XOR gate using minimum number of NOR gate. So just now we have seen how to implement XNOR gate using NOR gate. Now we will implement the XOR gate. So for that, first we need to understand one concept of NOR gate, that is how to use NOR gate as NOT gate. Why I am saying we need to understand this concept, how to use NOR gate as NOT gate, because we have implemented the XNOR gate just now. So if we will complement the output of XNOR gate, means if we will complement the output of this XNOR gate, then we will get the XOR gate. So that, or we are implementing here XOR gate. We implemented the XNOR gate, so we need to implement the NOT gate using the NOR gate, so that we will connect the output of XNOR gate into the input of NOT gate, and the output we will get as the XOR gate. So let's see how to use NOR gate as NOT gate. So that we have covered in our previous video as well. Let's see here again. So if we will see, this is the NOR gate. Okay, let's suppose this is the A and this is the V, and we have the output as A plus B whole complement. Now, what is the NOT gate expression? As we know, NOT gate is nothing but if we will provide the any input to the NOT gate, then that will be complemented and we will get the complement output. As here we have provided A and Y is A complement. So tell me one thing, we want this expression from this expression, so what we need to change here so that we will get this expression A complement. Okay, so if I will say instead of this V, if I will place A here, then I will get A complement. Let's see, if I will connect instead of this V A, then this A and A means A plus A will be A, and this complement sign will remain same. So what I need to change here, instead of this V, I need to provide A input in second leg of this NOR gate as well, so that we will get the NOT gate as a output of this NOR gate. Okay. Now just I am redrawing this circuit as NOT gate. So what we have discussed here, if I will provide the common input means A in this NOR gate, then I will get the output as NOT gate. So now we have seen here how to treat a NOR gate as NOT gate. So this we will connect in the NOR gate, XNOR gate here, so that we will get the XOR gate. So we have implemented the XNOR gate. So this is the circuit diagram of XNOR gate that we have implemented just now. XNOR gate means A into B plus A complement into B complement. This is the XNOR gate output. Now we have seen, we know if we will complement this output again, then we will get the XOR gate. So we will connect this output into this NOT gate. Here I am connecting the output of the XNOR gate to the again one NOT gate, means this is the NOT gate representation in NOR gate here, and now I will get the final output as XOR gate, means A complement into B plus A into B complement. So this is the final implementation, means this is how the circuit will look like of XOR gate implementation using NOR gate. So how many number of NOR gate used here? 1, 2, 3, 4 and 5. So if any interview or any test, the question will come like that, how many minimum number of NOR gate required to implement the XOR gate, then we can simply write down our answer as 5. And but about the XNOR gate, so here we have seen this is the circuit of XNOR gate. So here how many gates are used for the implementation? 1, 2, 3 and 4. So we can say from this implementation total number of 4 NOR gate required to implement the XNOR gate. Okay. So total number of 4 NOR gate required to the XNOR gate and total 5 number of NOR gate required for the XOR gate implementation. So I hope you have understood the XNOR and XOR gate implementation. Thank you everyone for watching this video till end.